So welcome to another Maths with Paddy video, where we either state a theorem or talk about a method and do an example always in less than 5 minutes. Okay, so today we're going to talk about implicit differentiation. So to begin, we will consider the following equation where we have x by y is equal to 1. Okay, so this is going to be true if and only if y is equal to 1 over x, okay? Or we can just say it's equal to x to the power of minus 1, okay? So this is an explicit expression where we have y explicitly expressed in terms of x, okay? So this allows us to compute the derivative dy dx quite easily, just using the power law, which would be just minus times x to the minus 2, which is equal to minus 1 all over x squared. Okay, so alternatively, we could use implicit differentiation or implicit differentiation DI. Okay, so this is where we take the original equation and differentiate across the entire equation, the left side and the right side. So we just say d dx, the derivative with respect to x of the left-hand side, which is x times y, will be equal to the derivative d dx of the right-hand side, which is just 1. Okay, so to differentiate this part here, we use the product rule, which is on a different video. So this will be equal to x times dy dx, okay, plus y times the derivative of x with respect to x, which is just 1. Okay, and this will be equal to the derivative of that, which is just 0. Okay, so this equation is true if and only if we can say that dy dx would be equal to, bring the y over to the other side, we'll get minus y, and then divide across by x, and we'll get x, okay? So now we know what y is equal to from this equation here. Y is equal to 1 over x. If we substitute in y is equal to 1 over x here, we'll get minus 1 all over x squared, okay? So now these two answers agree. One was solved implicitly, and then one was solved explicitly. Okay, so just let me get another window here. So new slide. Just bear with me for a second. Example. Okay, so as an example, so e dash g. Okay, we can take the equation 5 times y squared plus the sine of y is equal to x squared. Let's solve this by implicit differentiation. Okay, so differentiating the left-hand side. Okay, so start off with this guy. So this will be equal to 5 times. Now, to differentiate y squared implicitly, it's actually the chain rule. So we differentiate the outer function, which will be 2y. And then y is a function of x, so we need to multiply by dy dx. So that's a little bit of the chain rule, okay? Then we differentiate this guy with respect to x here, sine y. So again, it's the chain rule, so we differentiate the outer function, which is sine, and we'll get cosine of y. And then we multiply by the derivative of the inside function, which is y, so that's just dy dx. So that's application of the chain rule. Now I'm going to show you in another video exactly why that is, in case you're confused by that, okay? So that's that, and then we just differentiate the right-hand side. Derivative of 2x, or x squared, with respect to x is 2x. So now we just have a bit of multiplication and tidying up. So this would be equal to 10 times y dy dx, yeah, plus cosine of y dy dx, cosine y dy y dx 2x, okay, x. Now we can just take dy dx out, so we can say dy dx. So dy dx is a factor here, it's a factor here, so we can just say that dy dx is equal to 2x all over 10y plus the cosine of y. Okay, and we have solved the derivative of this expression implicitly. So hope that helps. Best of luck with your implicit differentiation examples.